January 31st, 2000. Alaska Airlines Flight 261, a McDonnell Douglas MD-83 with 88 people on board, is flying from Puerto Vallarta, Mexico to Seattle, Washington, with a stopover in San Francisco, California. As the flight is approaching cruising altitude, the airplane's climb rate is slower than it should be, and the pilots are having to put more force into the control column than normal. The pilots suspect there is a problem with the horizontal stabilizer and begin troubleshooting the issue. The pilots decide to divert to Los Angeles, but the airline is trying to convince them to continue on to San Francisco. The pilots ultimately overrule the airline and begin making preparations to land in Los Angeles when the plane suddenly begins diving and becomes inverted. The pilots never stop trying to control the plane, but despite their best efforts, the plane crashes into the ocean, killing all on board. What happened to Alaska Airlines Flight 261? Find out on this episode of Black Box Down. Hello, everyone. Welcome to Black Box Down. It's Gus and Chris. Hello, Chris.
Hello, Gus, and people listening.
Hello, everyone listening. We're back with another episode. Interesting one. I think they're all interesting. We'll get into the specifics here in just a bit. Before we really dig into it, I want to remind everyone to give us a follow on social media, please, at Black Box Down Pod, Facebook, Instagram, Twitter. We post supplemental info there, and we can interact with the audience there. So yeah, give us a follow, and sometimes if you're having trouble picturing things, we might post a photo on there that'll help illuminate exactly what it is we're talking about.
Yeah, quite literally picture things.
Yeah. Oh, and don't forget, I forget about this. If you'd like to directly support the podcast, you can head over to blackboxdownpod.com. You get episodes early, and you get ad-free versions of the episodes, and you can continue listening in whatever podcast listener you're already using. If, like I said, head over to blackboxdownpod.com. Or if you're listening on Spotify or Apple Podcasts, you probably see a button in there to do it directly in that app. Either way, whatever works for you. Mm-hmm. It's a great way to support us directly if you'd like. We'd appreciate it. And also, if you'd like to send us questions, I was curious to see if the audience had questions. To set up an email address, blackboxdownpod@gmail.com. You can reach out to us, and we might be doing some question answering here in the near future. We're trying to figure that out. So if you have any burning questions about commercial aviation, send it to us, and if we know the answer, we might be able to answer it for you.
You can also send questions on social media at Black Box Down Pod.
Yeah. So Alaska Airlines Flight 261 was a passenger flight, like I said, from Puerto Vallarta, Mexico to Seattle, but it was stopping at San Francisco on the way. I'm sure you've been on flights like that where you're going somewhere and you just stop. You make a stop on the way.
Yeah.
The flight was crewed by Captain Edward Thompson, who was 53 years old with 17,750 flight hours, and First Officer William Tansky, who was 57 years old with 8,140 flight hours. So they were both pretty seasoned pilots. They'd had a lot of experience under their belts. And the aircraft itself was an 8-year-old McDonnell Douglas MD-83 with 26,584 flight hours and 14,315 cycles.
So that plane's in the prime of its life.
Yeah, not that old at all. And there are also 3 flight attendants and 83 passengers on board. So this kind of plane, the McDonnell Douglas MD-83, we've talked about this before. You would recognize it if you saw it because it's the plane that it has 2 engines, but they're not under the wings. They're at the back of the plane. You've probably flown a plane like this. I think American Airlines used to fly this plane a lot. It was the kind where when you'd get on, there'd be 2 seats on one side and 3 seats on the other.
Oh, yeah.
And like I said, if you're looking at it from the outside, instead of having the engines under the wing, it's got the 2 engines at the very back of the plane. You would recognize it.
I feel like the 3 seats is risky because you can end up with more people, but there's also a greater chance that you could end up with an extra seat.
I haven't flown on one of these planes in a while, but I always felt like the 2-seat side definitely got taken up because you were guaranteed either window or aisle. You didn't have a middle seat,
and you don't have to. Yeah, just less people in general.
Yeah, but now I'll be honest. It was not my favorite plane to fly. I was not a fan of this plane, just from a comfort perspective. Anyway, I'm getting distracted. This is a regular episode. This isn't a supplementary plane story episode.
I distracted you too. I was like,
okay,
well,
okay. So this flight departed Puerto Vallarta at 1:37 p.m. Pacific time and began climbing up to 31,000 feet. At 1:53, which is 16 minutes later, while the airplane was climbing through 28,500 feet, the autopilot disengaged. During the next 7 minutes, the ascent rate was much slower than what it was before, and the airplane was being flown manually using up to 50 pounds of pulling force on the control column. So,
wow.
Yeah, they're really having to pull back to get the plane to climb. Mm-hmm. That's why, like earlier I said, they know something's wrong. Something's not right.
And they don't want to try and continue. They're like, there's something's definitely wrong. Not like, check out later, right? That's what.
Right. Well, yeah. Well, at this point, with this problem, they're gonna run a checklist, right? That's what always happens in this situation. So, but what they do first is they continue going up to cruising altitude. Of course, having more altitude is useful. You can glide further. So they go up, they reach cruising altitude, and the plane was flown for about 24 minutes with 30 pounds of pulling force on the controls.
That's just like holding it stable.
Correct, like to maintain level flight.
And at that point, it should be no force, right?
Right, it should just be neutral.
Yeah.
So then over the next hour and 22 minutes, there was a pulling force of about 10 pounds on the controls before the autopilot was re-engaged at 3:46 p.m. So yeah, it's a little off. Normally, even if you're having to pull a little bit on the controls, you would think that they'd be able to use a little bit of trim and make it neutral to where they don't have to be constantly pulling or pushing on it. So anyway, the crew, they contact Alaska Airlines dispatch and maintenance personnel to discuss what they suspect is a jammed horizontal stabilizer and a possible diversion to Los Angeles. And just so for reference, the horizontal stabilizer, it's like on the tail at the very back of the plane. It's not the part that goes up and down. That's the vertical stabilizer. It's the part that goes it's the same as the wings, like left and right out from the fuselage.
Yeah, and it's like helps it control the lift.
Right, yeah, there's elevators on it that deflect up and down that can help pitch the nose or the whole plane up and down.
And so they think that the elevators are jammed?
Yeah, there's something jammed back there on the horizontal stabilizer. Like maybe it's deflecting nose down a little bit, and that's where they're having to pull back to maintain level flight.
Okay.
You see, because it's like if it's jammed in a nose down position, the plane's wanting to descend. That's why they're having to pull back to even it out.
And this wasn't an issue before.
It started while they were climbing, when they were at about 28,000 feet climbing up.
And sorry, this was their first leg of the flight?
Yeah, they're going from Puerto Vallarta to San Francisco at this point, and they're over the ocean. That's why they're talking about maybe diverting to Los Angeles. Oh yeah, so that's actually what I said. They were talking with the airline and maintenance about hey, maybe they should divert to Los Angeles. Then about 3 minutes after the autopilot was re-engaged, the autopilot was disengaged and then re-engaged a few moments later. So they're messing with the systems, trying to get the autopilot to take care of it. At 3:50 p.m., maintenance in Seattle confirmed with the flight crew that they wanted to divert to Los Angeles, and they asked them why Los Angeles over San Francisco. Because remember, they're supposed to be going to San Francisco, but because of this problem, they want to divert to LA. And they're getting the crew's getting a little bit of pushback from the airline, like, hey, why don't you just keep going to San Francisco? And the captain responded with, well, a lot of times it's windy and rainy and wet in San Francisco, and it seemed to me that a dry runway where the wind is usually right down the runway seemed a little more reasonable. So the captain is being very prudent in his selection here. It's like, I know we're not supposed to be going to Los Angeles, but because of this problem, it's going to be more favorable to land in LA. Plus also, LA is closer. They're going to pass by LA on the way to San Francisco anyway. So the dispatcher in Seattle then gave the crew the current weather for San Francisco and told the crew if they wanted to land in LA for safety reasons, they can do it, but they'll be looking at an hour to an hour and a half due to a major flow program going on.
What
that means is there was a lot of traffic. There's a lot of air traffic congestion over Los Angeles, and there were ongoing departure delays. So what's happening is the airline, the dispatch is kind of trying to guilt them. Like, well, if you think you can land in LA, go for it, but you're going to be delayed because there's traffic there.
Yeah, but also if you're like, hey, this is an emergency, something's wrong with the plane, they'd open up a slot, right?
Right. And I think the dispatch is telling them if they once they land and get the problem fixed, when they go to take off, they're going to be delayed. And the captain replies saying, I really didn't want to hear about the flow being the reason you're calling us because I'm concerned about overflying suitable airports. So he's being very direct. Like, don't bother me about traffic when I'm concerned about safety here.
Yeah. Which it sounds like this pilot, he knows he's on top of his stuff.
Yeah, like I said, both of these pilots have extensive amount of time, not only in general, but also in this specific plane. Like these are very experienced pilots. At this point, the captain discussed the possibility of landing at San Francisco with the first officer and came to the conclusion they would not be able to land on the most favorable runway. It's just not going to be ideal situation out there. So the captain then asked Seattle dispatch if they could get some support or ideas for troubleshooting the problem, but then received no response. At 3:55, the captain commented, it just blows me away. They think we're going to land. They're going to fix it. Now they're worried about the flow. I'm sorry, this airplane's not going to go anywhere for a while, so you know. So the captain's still annoyed. The first officer, like, can you believe these guys? Like, we have a pretty serious problem here, and they're concerned about traffic. A flight attendant replied, so they're trying to put the pressure on you. The captain responded saying, well, no, yeah. And a minute later, the dispatcher told the crew that San Francisco was using 28 left and right for landing, which would put them in a direct crosswind, which is what the captain suspected.
So he's still saying, just in case.
Here's the weather in San Francisco. And of course, it's bad. So the captain asked for the weather for Los Angeles, and after a little more discussion, it was decided LAX would be the correct airport to land at. So they were really not wanting to let him land in Los Angeles. At 4:07, the crew got in contact with maintenance personnel at LAX, and the maintenance crew asked if they had already run some troubleshooting. The crew said they did, and maintenance asked about the status of the alternate trim system. The captain responded saying it appeared to be jammed, and that the AC load meter spikes out when they use the primary trim system. He then says the motor is trying to run but won't move, and when they use the alternate system, nothing happens. So they have different systems they're trying to move the trim with, and when they're saying the AC load meter spikes when they're using it, that means that like the electricity is getting to it. There's electric draw, but nothing's happening. So then, after discussing the trim systems a little more, the mechanic told the captain that he would see them when they arrive at the LAX maintenance facility. And at 4:09, as the captain ended the conversation, he told the first officer, this'll click it off, and then the autopilot was disengaged. At the same time, the cockpit voice recorder recorded the sound of a clunk, followed by 2 thumps, then a sound similar to a horizontal stabilizer in motion tone.
Oh.
A couple seconds later, the same motion tone sounded again, and the captain asked the first officer, you got it? The airplane had started to nose down and started a dive that lasted about 80 seconds.
Whoa.
Yeah, and the airplane went from 31,000 feet to between 23,000 and 24,000 feet. So a pretty steep dive. That's a pretty serious dive. And during the dive, the captain said, it got worse, and then stalled. Then the captain said, no, you got to release it. You got to release it. Then about 20 seconds later said, help me back. And the first officer said, okay.
What is he talking about? The autopilot?
They're talking about like coordinating their controls on their effort, and they're able to stabilize it between 23,000 and 24,000 feet. And what I think they're trying to troubleshoot here is they're stalling, and then when they start pulling back, the wings probably exceed the critical angle of attack, and they probably got close to a stall. So even though they had been diving, they have to like nose down a little bit, which seems kind of counterintuitive. But they do stabilize it.
And they stalled because they weren't going fast enough.
Well, it's more. Remember, it's not. We typically associate stalling with airspeed, but that's not always necessarily true. It's really about airflow over the wing, and they probably pulled back so much that it recovered. Then airflow became disrupted over the wing, and then they had to kind of nose down. There's also we're not going to get too into this because this is like really drilling into the aerodynamics of it. But this particular plane, these MD-83s, they're horizontal stable. Like when you think of a plane, you typically think of the wing and you think of the horizontal stabilizer on the tail as being kind of on the same level as the wing. On these MD-83s, the horizontal stabilizer is at the top of the rudder.
Yeah, okay.
It's not directly behind it. So there's some weird aerodynamic properties that go with that. And you run the risk with these high horizontal stabilizer planes of entering what's called a deep stall, where the airflow gets disrupted over your horizontal stabilizer. That's really like that's a whole other podcast. That's like aeronautical engineering podcast. We're not going to get into that, but I'm just trying to set the stage that there are some unique aerodynamic properties about this plane that may or may not have come into play at this point. But regardless, they do, like I said, these pilots know much more about this plane than I do. They're able to stabilize it.
And they're aware of it, so they're like, planning.
So the captain then contacted air traffic control and told them they've lost control of vertical pitch and they were in a dive.
Oh, man.
At 4:11, the captain then said they were stabilized at 24,000 feet and asked for a block of altitude between 20,000 and 25,000 feet. So he's, because they're unsure if they can control the vertical orientation of this plane, they ask for air traffic control to block out, this 5,000 feet of air vertically so that no planes get around them so that they don't hit anybody.
Yeah, because they can't go back up, or they don't know if they can go back up to cruising to
right, and they don't know if they're going to start diving again, and they wouldn't want to hit anyone. And while this is going on, the flight data recorder recorded a pulling force between 130 and 140 pounds was required to recover from the dive.
Oh, man.
The first officer then said, whatever we did is no good. Don't do that again.
Oh.
then said it's a lot worse than it was.
Oh, no. So, like, the pressure needed to stabilize it?
Right. They're having to pull a lot more. They had to pull a lot to recover from the dive, and it's become very difficult to maintain level flight. The captain agreed, saying they were in worse shape, and said it could probably get worse, and suggested getting down to 200 knots to see what happens. So they're slowing down a little bit. Presumably, I don't know for a fact, but I would assume that the captain's trying to slow down a bit because they're going to have to slow down to land. I assume he's testing to see what's going to happen. At 4:12, the captain told maintenance at LAX they did both the pickle switch and the suitcase handles, and then it went full nose down trim. And these are terms. So the suitcase handles, it's a colloquial term. He's not actually grabbing his luggage. It's a colloquial term for the longitudinal trim handles located in the center control pedestal. So it's like, it looks like a suitcase handle in that like the controls between the pilots that they can use for the trim.
Okay.
And the pickle switch is another term for the trim switches located on the control wheel. So it's like a little switch they can activate with their thumb on the control column.
And what relation to pickles does it have?
I don't know why it's called a pickle switch. It doesn't look like a pickle, I don't think.
Because like one of them, it looks like a suitcase handle, and the other one's and it looks. Well, we don't know why it's called a pickle switch.
Yeah. So they're just letting maintenance know that they're trying both ways to control the trim switch. They control the trim, and it's not working. And the captain said they were in a pinch and afraid to troubleshoot again in case the trim went in the other direction. They decided not to try any more troubleshooting, and then contacted air traffic control, saying they were having trouble maintaining altitude and intended to land at LA.
Whenever they dove the first time, did something prompt it? Was it them turning off the autopilot?
From their perspective, it seemed unrelated. They had recently turned off the autopilot, and they had recently done some troubleshooting, but they had not done anything immediately that caused that dive. Like, it had been a minute or two since they had done anything.
Okay.
So they had done stuff recently, but not done anything immediately. This episode of Black Box Down is brought to you by Incogni. Every single day, your personal data is being sold online without you even knowing. There's thousands of data brokers aggregating your personal info, like phone number, IP address, employment history, shopping habits, etc., and selling it to unknown businesses to be used as they please. Sounds scary, right? The good news is that you have the right to request data brokers to delete what information they have about you and to protect your privacy. Unfortunately, if you want to do this yourself, it would take you years to do it manually. Incogni can do the messy work for you, and it's fully automated. Incogni will help you protect your privacy and take your personal data off the market by reaching out to data brokers on your behalf and requesting your personal data to be removed and dealing with their objections. Incogni is super affordable and effortless. The best part is that the first 100 people to use code BLACKBOXDOWN at incogni.com, that's incogni.com/blackboxdown, get 20% off Incogni. Look for a link in the description of this episode and take back control of your personal data. Again, that's code BLACKBOXDOWN at incogni.com/blackboxdown, incogni.com/blackboxdown. Want a new credit card but not sure how to choose? You don't need to apply for the first offer you see in the mail. Credit Karma can help you zero in on the right option for you and apply with more confidence. Credit Karma uses your credit profile to show you offers that are tailored to your financial situation. Credit Karma partners with a wide range of card issuers so you can be sure you're exploring all sorts of options. Best of all, Credit Karma uses your credit data to show you your chances of approval before you even apply, helping you apply with even more confidence. Comparing cards on Credit Karma is 100% free, doesn't affect your credit score. So, ready to find the right card for you? Head on over to Credit Karma, check out your personalized mix of offers. You can either go to creditkarma.com or use the Credit Karma app on your phone. Find the card that's right for you. Again, that's creditkarma.com. Credit Karma, create your own karma. From cringing at the pump to getting an eye-popping check at your favorite restaurant, inflation is hitting us all where it hurts, and it really hurts. That's why I start using Upside. Upside is an incredible app for anyone who buys gas, groceries, or dines out. With every purchase, I'm earning cash back thanks to Upside. I know it sounds too good to be true. It's not. It actually works. It's a no-brainer. To get started, download the free Upside app in the App Store or Google Play. Use our promo code BLACKBOX and get $5 or more cash back on your first purchase of $10 or more. Next, claim an offer for whatever you're buying on Upside. Check in at the business, pay as usual with a credit or debit card, and you get paid. In comparison to credit card rewards or loyalty programs, you can earn 3 times more cash back with Upside. You can cash out anytime to your bank account, PayPal, e-gift card, Amazon, other brands. Upside users are earning more than $1 million every week. That's why they probably have a 4.8 star rating on the App Store. So again, download that free Upside app. Use promo code BLACKBOX to get $5 or more cash back on your first purchase of $10 or more. That's $5 or more cash back on your first purchase of $10 or more using promo code BLACKBOX. So at this point, the captain asked to descend to about 10,000 feet and to make sure he could try to control the plane. And they were cleared down to 17,000 feet, so they're starting like that stair-step down process.
How far away are they at this point?
At this point, they're off the coast of California. The captain, remember, like I said, they had requested a block of
wind
of altitude. Air. Yeah, and they were afraid that they might lose control of the plane. So rather than go in over land, the captain made the choice to go out like over the ocean west of LA. So they're a couple of miles west of LAX. I'm sure you've flown out of LA. It's right by the water. They're a couple miles out over the ocean because they didn't want. The captain decided if they lose control, they don't want to hit a plane, and he didn't want to hit a neighborhood or a populated area.
Yeah.
So they're several miles off the coast,
but they're close.
Not super. Yeah, they're not super far.
Okay.
They're a few miles away. So the captain then told the flight attendant to make sure everyone was strapped down because he was going to release the back pressure and see if he could get it back. The flight attendant said they heard a big bang in the back, and the captain said he heard it, and he thinks it's just that the stabilizer trim was broken.
That's scary when you're in a plane and you hear a big anything.
Yeah, especially when there's already problems going on, and then you hear something. It's not good. At 4:18, the captain asked for slats and flaps to be extended, and then commented they were pretty stable, and commanded for them to be retracted again. Remember, these are things he's going to need to deploy when they go into land. So he's kind of testing them now to make sure, like, hey, are we going to lose control when this stuff happens? And, so far, everything seems to be controllable.
Okay.
The captain and the first officer then had a conversation about trying to do a little bit more troubleshooting with the trim. But the first officer suggested not to, and to just try to land, and the captain agreed. 5 seconds later, the cockpit voice recorder recorded several distinct thumps. The first officer asked the captain if he felt that, and the captain said he did. The captain then asked for slats, and at that moment, the sound of an extremely loud noise was recorded in the cockpit voice recorder. Over the next few seconds, the flight data recorder recorded a maximum pitch down rate of 25 degrees per second and a significant decrease in vertical acceleration. At 4:19 and 42 seconds, the airplane reached its maximum valid recorded airplane nose down pitch angle of negative 70 degrees. So they're really pitched down. Negative 90 would be like aimed right at the ground. So they're pretty much almost nose straight down.
Sounds like the stabilizer like broke off or something.
We've done a lot of these episodes together, haven't we, Chris? The roll angle also passed through 76 degrees left wing down. The first officer said Mayday, but did not actually make a radio transmission.
Oh, no.
The captain started commanding to push and roll. At 4:19 and 45 seconds, the pitch angle increased to negative 28 degrees, but the airplane was completely inverted. So they were upside down and relative to the ground or relative to the horizon, negative 28 degrees. The captain said, okay, we are inverted and now we're going to get it. The aileron started to move left wing up and then left wing down. The airplane rolled through negative 150 degrees with an airplane nose down angle of negative 9 degrees. So they're kind of breaking the dive, but they're upside down.
Yeah, that's crazy.
At 4:20 and 4 seconds, the captain then said, push, 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 push the blue side up.
Wait, so how, they're breaking the dive by flying upside down.
Yes.
And that's not, are you supposed to? I mean, I know you're not supposed to do that, but is that something that's possible?
Here, let me get through another couple seconds and we'll talk about that. I actually do have something to say about that. So presumably when he's saying push the blue side up, he's talking about the ADI, like the artificial horizon, which we've talked about before. Because normally the blue side's up for sky and the brown side's down for Earth. When they're upside down, it would be backwards. The blue side's down and the brown side's up. So that's why he's saying push the blue side up, like trying to, like, let's get back to a correct attitude. They started saying to kick the left rudder. The first officer said he couldn't reach the left, and the captain said, okay, right rudder. At 4:20 and 38 seconds, the captain said, got to get it over again. At least upside down, we're flying.
Oh my God.
Yeah, this is crazy. Then sounds similar to engine compressor stalls and engine spool down was recorded on the cockpit voice recorder. At 4:20 and 54 seconds, the captain commanded deployment of the speed brakes. And about 1 second later, the first officer replied, got it. At 4:20 and 56 seconds, the captain stated, here we go. And the flight data recorder ended at 4:20 and 56 seconds, and the cockpit voice recorder ended at 4:20 and 57 seconds. The airplane impacted the Pacific Ocean near the coast of California. Everyone on board was killed and the airplane was destroyed. So you asked about flying upside down. This incident and this like last little bit that I read was actually the inspiration for that Denzel Washington movie, Flight. I don't know if you remember it. It came out about 10 years ago, where he plays an airplane captain that has a problem on takeoff. And the way that he's able to land the plane is he has to fly upside down for a little while and roll the plane and then ultimately land it. It's a pretty good movie.
I was about to say this. I mean, the idea of flying a plane upside down sounds like something that should be in a movie.
Yeah, well, if you've never seen it, I'd recommend you check it out, Flight. Because, like I said, it was directly inspired by this. So to answer your question, no, you're not supposed to fly upside down. A lot of these systems rely on gravity to work. If you think about it. Okay, so I don't know. I'm not a plane mechanic. I'm not a pilot. I'm not a plane mechanic. But if you think about some of the things we've talked about in the past about like fuel pumps and how fuel gets down to the engines in a plane, lots of times it's gravity assisted. And it relies on the engine being lower than the fuel tank for fuel to get down there. When you're inverted, you run the risk of starving it. So, I mean, that's just one problem. A wing also isn't designed to work upside down if you think about the shape of the airfoil and how the wind goes over it. I mean, I guess conceivably, if you have enough speed, you could generate lift upside down, but I mean, the plane is not designed for this. Like if you're going to be doing maneuvers like this, typically you have to have like a special plane that's designed for like acrobatic flight.
Okay.
With like booster pumps and all kinds of other. There's just tons of problems that can result from this. But obviously in this case, when they can't control it and they're, nose down going into the ocean, if it's the only thing they can try, I mean, obviously they're going to try it. The investigation was done by the NTSB, and about 85% of both the fuselage and the empennage were recovered. And the empennage is like the tail section of the plane. The NTSB was able to examine the horizontal stabilizer, and they found the horizontal stabilizer jack screw assembly was found intact. In this assembly, there's a part called the Acme nut, and the NTSB found that about 90% of the thread thickness had worn away, and the remainder of the threads had been sheared off. The remnants of the Acme nut threads were found wrapped around the Acme screw. The end-of-play measurement for wear on the Acme nut was only 22% of the thread thickness worn away, so it was far past needing replacement. The NTSB determined that as the plane was passing through 23,400 feet, the Acme screw and nut jammed and prevented further movement of the horizontal stabilizer until the initial dive. The investigators considered numerous factors that might have played a role in the jamming of the Acme screw to the nut, including bending of the worn threads before and during the shearing, distortion of the remnants after they were sheared, and loads resulting from the Acme screw threads pulling upward across the remaining ridges after the shearing. However, the board could not determine the exact cause of the jam. So while the jack screw itself was intact, there was this other nut and bolt that, or I guess they call it a screw, the Acme screw, that had kind of sheared. And if you picture like a nut on a bolt or, you know how like you tighten it?
Yeah.
It had been like essentially pulled off. Instead of unscrewing it, it had been sheared straight down and like stripped all of the threads. And like all of those little metal filings had come out and caused it to jam. And without threading, it can't tighten it. It can't hold. Like, so it was barely hanging on and then became sheared off.
So then that put a lot of pressure on the stabilizer?
Well, when it did that, it caused a jam, which then made the horizontal stabilizer stuck, which is what you suspected, which is why they were having to give it so much opposite pressure. And then eventually, because of the loads, it failed and pulled away, which is when they lost control of the plane.
When you say it failed and pulled away, as in
It broke.
It broke off.
Yeah.
The whole thing?
But the Acme screw and nut.
Okay.
Which led to the problem with the jack screw, which caused the problem with the horizontal stabilizer. It's all part of, you can generally say it's all part of the horizontal stabilizer, like from a macro view, just like we're talking about like the specific individual parts that control it. So before the initial dive, the captain switched off the autopilot, and the flight data recorder indicated during the 3 to 4 seconds following the disconnect, the horizontal stabilizer traveled from 0.4 degrees nose up to beyond the maximum airplane nose down position that could be recorded by the flight data recorder. As the jam was overcome, the Acme screw was being pulled upward through the Acme nut by aerodynamic loads, causing upward movement of the horizontal stabilizer, resulting in greater airplane nose down motion. This upward pulling motion would have continued until the lower mechanical stop on the Acme screw contacted the lower surface of the Acme nut, preventing further upward motion of the horizontal stabilizer. So like I said, it was kind of stripping it, and then like it was barely holding on, and these aerodynamic forces were pushing it, causing them, their resistance.
I have a question too. You say we've talked about nuts and bolts in the past. How big are these nuts? These are probably pretty big, right?
So I can find photos of it. It's really difficult to tell scale because there's nothing to compare it to in these photos. It's just, pictures of the part. If I had to guess, and again, this is just a guess based on a few photos I've seen, I'll post some of these photos on social media if you give us a follow at Black Box Down Pod. If I had to guess, this nut is probably 1.5 to 2 inches across.
That's not that big.
No, it's not that. It's not like a tiny, it's not super tiny, but it's not massive or anything. It's you could easily hold it in your hand.
It seems crazy that a plane went down because of that.
Yes, when as we've already said here, the NTSB is saying that it was far past needing replacement by the time this incident happened, and we'll get into how that happens here in just a bit. So investigators attempted to determine what caused the horizontal stabilizer to move immediately after the autopilot disconnect. And normally the autopilot is disconnected by the pilot flying using the autopilot disconnect switch located on the outboard side of the control wheel. However, the autopilot will also disconnect when the primary trim control system is activated by either the control wheel trim switches or the longitudinal trim handles on the center pedestal, the pickle switch or the suitcase handles.
Mm-hmm.
Based on the captain's comment about activating the pickle switch after the dive, it appears the captain disconnected the autopilot when he activated the primary trim control system by either using either the pickle switch or the suitcase handles or both. Consequently, although the operation of the primary trim motor as part of troubleshooting attempts earlier in the flight did not release the jam, the torque created by the primary trim motor when the captain activated the trim system this time apparently provided enough force to overcome the jam between the Acme nut and the screw. So it was kind of jammed and stuck, but in their troubleshooting, trying to get the trim system to work, it gave it more force and then it overcame that jam, which is then what caused it to be affected by those aerodynamic forces. Like then at that point, once it overcomes the jam, then it was loose, and then that's when it started giving maximum nose down. The NTSB determined that the cause of the final dive was the low cycle fatigue fracture of the torque tube, followed by the failure of the vertical stabilizer tip fairing brackets, which allowed the horizontal stabilizer leading edge to move upward significantly beyond what is permitted by a normally operating jack screw assembly. The resulting upward movement of the horizontal stabilizer leading edge created an excessive upward aerodynamic tail load, which caused an uncontrollable downward pitching of the airplane from which recovery was not possible. That's just repeating what I said.
Yeah.
Once it broke free, it was loose, and it gave them that maximum nose down pitch. The NTSB looked into what could have caused the excessive wear of the Acme nut threads, and they found no evidence of grease in any condition inside the Acme nut or the Acme screw.
But you want grease, right? So that it can slide up and down?
Right. So that you don't have metal on metal contact. So even though the jack screw assembly was immersed in seawater for 7.5 days, seawater would not significantly alter or remove grease. There was not sufficient lubrication for these parts. If the Acme nut's grease fitting had recently been used to lubricate the jack screw assembly, as should have been during the jack screw assembly's last lubrication on September 14th of 1999, the counterbore should have contained fresh grease. So they say, they go through the maintenance records, and the last lubrication was supposed to be September 1999, and this crash happened on January 2000. That's only 4 months before. So only 4 months before it should have been greased, and they look at it now, and there's no grease on it.
Oh.
The NTSB interviewed the San Francisco mechanic who was responsible for performing the last lubrication of these parts, and he revealed a lack of knowledge about how to properly perform the procedure. Right. So, for example, he said it took him about an hour to do, but the task should actually take about 4 hours.
Oh, no. He probably didn't even do it? Or
maybe. Yeah, that's what they're realizing. Like, imagine if, your boss asks you, hey, how long did it take to, put this project together? You say, an hour. And your boss is like, but it should have been 4 hours at minimum. Like, they know, like, wait a minute, maybe you didn't do this right.
Yeah, if you did it right, then it couldn't be done in an hour.
Right. There was an 8-month lubrication interval for the MD-80s at Alaska Airlines, and this was only 4 months after its last scheduled lubrication. Like I said, only 4 months had passed. The NTSB believes it's possible for there to have been previously inadequate lubrication or lubrication that was missed entirely. So at this point, they begin asking, Did anyone ever lubricate this part?
Oh
When was the last time that it was actually done?
Yeah, because if he didn't even know how to do it.
Right. However, they couldn't determine exactly how many more scheduled lubrications were missed or inadequately performed. Because, how can you look back and figure that out?
Yeah. Did other mechanics at Alaska Airlines, did they know how to lube it correctly, or is it just that one?
Well, that's the question you have to start asking, right? Like, is this a problem that is isolated to a single mechanic, or is this a problem that's more widespread across all of maintenance in general? We will actually talk about that a little bit in just a little while. But you're right. That is the correct way to think. Is this isolated to this one mechanic, or are we looking at a much bigger problem? So they're trying to figure out, and they can't determine exactly how many lubrications were missed. In 1987, Alaska Airlines had a lubrication interval of 500 hours, which was consistent with the manufacturer's recommendation. However, in 1988, this increased to 1,000 hours. In 1991, this increased to 1,200 hours. In 1994, 1,600 hours. And then in 1996, the interval was set at 8 months, which is roughly equivalent to 2,550 flight hours. So this is a 400% increase in the lubrication interval than in 1987. So at this point, it doesn't become necessarily important to figure out if it's this specific mechanic's fault, because now you're seeing, they are just trying to stretch the amount of time as much as possible here. Like, this isn't safe. Even if the mechanic knows how to do it, they're waiting 2,550 hours to do this, when before, they had been doing it at 500 hours.
Is there not a set you must do it this often? They can just change it like that arbitrarily?
So there are manufacturer recommendations, and that was the 500 hours. However, around this time, there had been, it's the thing you always hear, right? There had been some financial difficulties.
Oh.
So they were trying to spread their budget thin as much as possible in order to try to not lose as much money.
Oh my, it's like Lord of the Rings quote, not enough lubricant spread over too much nut.
Yeah, it's close enough. But I feel like that is a theme that comes up every now and then in some of our episodes, right? An airline that's having financial trouble, they start cutting corners, and then something like this happens. So, to your question about, is there no guideline for this, right? The investigation tries to look into it, and they try to figure out, what information did the airline use as justification for this extension of the lubrication interval? However, according to the FAA principal maintenance inspector for Alaska Airlines, who reviewed and accepted the 1996 interval extension, Alaska Airlines presented documentation of the manufacturer's recently extended recommendation interval as justification for its increase. So the NTSB asked the FAA inspector for them, why did you let them do this? And the FAA inspector says, Alaska Airlines showed me manufacturer documentation saying they could extend this. However, the documentation indicated that the original design engineer's recommended lubrication interval was not considered, and Boeing engineers were not consulted. This extension makes a missed or improper lubrication much more dangerous than if the intervals were not extended. So they had documentation, but the documentation was not reviewed by the original engineers or Boeing engineers. They weren't consulted. So they had this documentation signed by, it must have been, I don't know who signed it. It must have been executives or someone, but definitely not the engineers.
So they can do that?
Well, apparently, but you see what happens here when that happens.
They're like, well, it said, we got documentation saying it was okay, so we said okay. And then, but it's like a made up, it's like when someone goes in and, I read, someone posted this on Reddit or something. They had edited Wikipedia and added their brother into their town history as a joke, but then some person writing a book about the town history referenced them and put them into the book, and now Wikipedia is citing that as a source, so that's
it self-fulfills it.
Yeah.
I was going to say it's like getting pulled over for speeding, and then you show the police officer a note from your mom that says it's okay. It's like, the note says it's okay, but what's the validity? What's the justification behind it?
My mom said it was okay.
So Alaska Airlines had also required end plate checks at every other C check, but these intervals changed over time as well. Originally, these C checks occurred every 2,500 hours, and the end plate check occurred every 5,000 hours. In 1996, the end plate check was at about 9,550 hours. The NTSB believes that if Alaska Airlines had not extended its end plate check interval to beyond the recommended interval, the airplane would have been required to undergo an end plate check at least 1,800 to 2,000 flight hours before the accident, and the excessive end plate could have been identified at this time. So they were just trying to extend every mechanical check as long as possible as a cost-cutting measure. And this plane crashed and these people died because of it. So we got our findings here. No evidence indicated that the airplane experienced any pre-impact structural or system failures other than those associated with the longitudinal trim control system, the horizontal stabilizer, and its surrounding structure. So everything was fine except for this part. The horizontal stabilizer stopped responding to autopilot and pilot commands after the airplane passed through 23,400 feet. The pilots recognized that the longitudinal trim control system was jammed, but neither they nor the Alaska Airlines maintenance personnel could determine the cause of the jam. The worn threads inside the horizontal stabilizer Acme nut were incrementally sheared off by the Acme screw and were completely sheared off during the accident flight. As the airplane passed through 23,400 feet, the Acme screw and nut jammed, preventing further movement of the horizontal stabilizer until the initial dive. The accident airplane's initial dive from 31,050 feet began when the jam between the Acme screw and nut was overcome as a result of operation of the primary trim motor. Release of the jam allowed the Acme screw to pull up through the Acme nut, causing the horizontal stabilizer leading edge to move upward, thus causing the plane to pitch rapidly downward. This is all reviewing all the things we've already kind of discussed in detail.
Yeah.
You know, the Acme nut being jammed, the motor giving it enough force to shear off, the aerodynamics pitching it down. And the cause of the final dive was the low cycle fatigue fracture of the torque tube, followed by the failure of the vertical stabilizer tip fairing brackets, which allowed the horizontal stabilizer leading edge to move upward significantly beyond what is permitted by a normally operating jack screw assembly. The resulting upward movement of the horizontal stabilizer leading edge created an excessive upward aerodynamic tail load, which caused an uncontrollable downward pitching of the airplane from which recovery was not possible. So I think that part, definitely, even though, you and I didn't suspect anything, that part clears the pilots of any wrongdoing, right? They say recovery was not possible. No matter what they did, there was no way to recover this plane.
Which is, it also makes you kind of sad that they were trying so hard.
To their credit, they did not give up. They would try to fly this plane upside down. They did everything possible in order to try to save this plane. In light of the absence of a checklist requirement to land as soon as possible and the circumstances confronting the flight crew's decision not to return to Puerto Vallarta, Mexico immediately after recognizing the horizontal stabilizer trim malfunction was understandable. So again, kind of relieving them of any wrongdoing.
Good.
The flight crew's use of the autopilot while the horizontal stabilizer was jammed was not appropriate. They didn't really know that though. Without clear guidance to flight crews regarding which actions are appropriate and which are inappropriate in the event of inoperative or malfunctioning flight control systems, pilots may experiment with improvised troubleshooting measures that could inadvertently worsen the condition of a controllable airplane. So that's just kind of saying they had no guidance while troubleshooting the issue and inadvertently made things worse, but it probably was inevitable anyway at this point. The excessive and accelerated wear of the accident jack screw assembly Acme nut threads were the result of insufficient lubrication. Alaska Airlines extensions of its lubrication interval for its McDonnell Douglas MD-83 horizontal stabilizer components and the FAA approval of these extensions, the last of which was based on Boeing's extension of the recommended lubrication interval, increased the likelihood that a missed or inadequate lubrication would result in excessive wear of jack screw assembly Acme nut threads. So they just needed to lubricate it. That's so frustrating. If the jack screw assembly lubrication procedure were a required inspection item for which an inspector's sign-off is needed, the potential for unperformed or improperly performed lubrications would be reduced. So again, that's just saying if there was more oversight, this would have been caught.
Yeah.
Alaska Airlines' extension of the end plate check interval and the FAA's approval of that extension allowed the accident Acme nut threads to wear to failure without the opportunity for detection. The design of the MD-80 horizontal stabilizer jack screw assembly did not account for the loss of Acme nut threads as a catastrophic single point failure mode. This one, we kind of didn't talk about this, and this is actually kind of important. As a result of this accident and everything that they uncovered, they realized that normally in airlines or in big commercial planes, there's backups and redundant systems. They discovered hey, there's no backup for this. There's no redundant system if this one thing fails, which it's kind of it's scary.
Yeah. Well, that's the thing. It's the pilots did everything right, and it all came down to them not lubing a nut.
Which in turn was also a single point of failure with no redundancy. At the time of the Flight 261 accident, Alaska Airlines maintenance program had widespread systemic deficiencies. I didn't want to say this earlier when you asked, like, was it just the one guy or was it multiple maintenance people? It was really the entire maintenance program was messed up because of this cost-cutting measures. There were problems everywhere. The FAA did not fulfill its responsibility to properly oversee the maintenance operations at Alaska Airlines. And at the time of the Alaska Airlines Flight 261 accident, FAA surveillance of Alaska Airlines had been deficient for at least several years.
Ooh.
And this is why, I mean, you ever wonder, like, this is why the NTSB investigates crashes and not the FAA. You don't want an agency who could be culpable to investigate its own problems. So that's why the NTSB comes in and can lay blame and say, hey, FAA, you were at fault here too. The NTSB determined that the probable cause of this accident was a loss of airplane pitch control resulting from the in-flight failure of the horizontal stabilizer trim jack screw assembly's Acme nut threads. The thread failure was caused by excessive wear resulting from Alaska Airlines' insufficient lubrication of the jack screw assembly. I know that's getting a little repetitive. It's just that's in the report. You know, that's how important it is. In the report, they repeat it over and over to make sure you know this is it. Contributing to the accident were Alaska Airlines' extended lubrication interval and the FAA approval of that extension, which increased the likelihood that a missed or inadequate lubrication would result in excessive wear of the Acme nut threads, and Alaska Airlines' extended end play check interval and the FAA's approval of that extension, which allowed the excessive wear of the Acme nut threads to progress to failure without the opportunity for detection. Also contributing to the accident was the absence on the McDonnell Douglas MD-83 of a fail-safe mechanism to prevent the catastrophic effects of a total Acme nut thread loss. So that's last one's what I talked about, how there's no redundant system or there's no fail-safe in case something goes wrong with this. All right, so there's only a couple of recommendations here. There's only 6, which makes sense. It seems like it's pretty clear what happened here. Require Boeing Commercial Airplane Group to revise the lubrication procedure for the horizontal stabilizer trim system to minimize the probability of inadequate lubrication. Require the Boeing Commercial Airplane Group to revise the end plate check procedure for the horizontal stabilizer trim system to minimize the probability of measurement error and conduct a study to empirically validate the revised procedure against an appropriate physical standard of actual Acme screw and Acme nut wear. So this is just like they need to be better about this check, and they need to have, when they say like empirical data, they need to have like a very defined exact number. Like once it reaches this amount, it must be replaced or maintenance must be performed on it. Require maintenance personnel who lubricate the horizontal stabilizer trim system to undergo specialized training for this task so that you don't end up with the mechanic who does it in an hour instead of 4. Issue a flight standards information bulletin directing air carriers to instruct pilots that in the event of an inoperative or malfunctioning flight control system, if the airplane is controllable, they should complete only the applicable checklist procedures and should not attempt any corrective actions beyond those specified. In particular, in the event of an inoperative or malfunctioning horizontal stabilizer trim control system, after a final determination has been made in accordance with the applicable checklist that both the primary and alternate trim systems are inoperative, neither the primary nor alternate trim motor should be activated, either by engaging the autopilot or using any other trim control switch or handle. Pilots should further be instructed that if checklist procedures are not effective, they should land at the nearest suitable airport. So this is the most blame that they put on the pilots. And it's really not even their fault because there was no clear guideline for it. But they're saying in the future, there should be no troubleshooting beyond what's in the checklist. And if it appears that the horizontal, trim is stuck,
then don't touch
or
it.
Horizontal, don't touch it. Don't do anything to touch it and land as soon as possible.
Yeah.
All right, so 2 more here. Establish the jack screw assembly lubrication procedure as a required inspection item that must have an inspector's sign-off before the task can be considered complete. So this is that oversight we were talking about. When it's done, an inspector needs to look at it and sign off on it. And the last one here, modify the certification, regulations, policies, or procedures to ensure that new horizontal stabilizer trim control system designs are not certified if they have a single-point catastrophic failure mode, regardless of whether any element of that system is considered structure rather than system, or is otherwise considered exempt from certification standards or systems. So this is just like certification in general. They're not going to certify any more planes that have single point of failure like this in this system. So when this was all said and done, the victims' families approved the construction of a memorial sundial designed by Santa Barbara artist James Bottoms, which was placed at, I don't know how to say this exactly, Port Hueneme on the California coast. This is like off the coast. This is where the plane went down. The names of each of the victims are engraved on individual bronze plates mounted on the perimeter of the dial, and the sundial casts a shadow on a memorial plaque at 4:22 p.m. each January 31st, which I think is pretty cool.
Yeah, that is cool.
Captain Thompson and First Officer Tansky were both posthumously awarded the Airline Pilots Association Gold Medal for Heroism in recognition of their actions during the emergency. This is the only time this award has ever been given posthumously.
Oh, wow.
And the Ted Thompson Bill Tansky Scholarship Fund was named in memory of the two pilots.
So they did such a good job despite it being impossible that they got it. Wow.
Yeah, I think it's because, they even attempted this inverted flight, and they, like I said, they did not stop trying to fly this plane until the very end. They did not give up.
That's what I like. I like those guys because they're when they're like, oh, go to San Francisco. Like, no, we're not going to. Yeah, like I don't know. It's.
Ultimately, they know it's their responsibility to handle the safety, and they're not going to let themselves get pushed around. And we've definitely heard problems. We've covered other episodes like that. These guys were very on top of it. Both McDonnell Douglas and Alaska Airlines eventually accepted liability for the crash, and all but one of the lawsuits brought by surviving family members were settled out of court before going to trial. But yeah, that's it. I mean, Alaska Airlines 261. This one I've been wanting to do this one for a little while, just because it's such a crazy mental picture to think about the pilots trying to fly this plane upside down, to the point, like I even mentioned a couple times, it inspired a crash in a movie, that movie Flight, which is central to that entire film. Really, really interesting.
I guess this kind of goes to a bigger problem. When a mechanic or something does something negligent, they can get in trouble personally. But then whenever someone just signs off, writes a memo that says it's okay to minimize maintenance and there's no personal culpability.
Right. Yeah. I don't know. That's honestly a bit of a blind spot for me in this episode. I don't know. Like, you would think that person would also be in trouble, or that they would make sure that there was regulation so that someone couldn't do something like that again. But I don't know. I don't know what the follow-up on that is. I assume that moving forward that it does require, an actual engineer to sign off on something like that. But that's it. Like I said, give us a follow on social media. I'll put a picture of the Acme nut and screw on there so you can see how big it is for yourself, and see like what a small part can bring down an entire plane. Again, it's not tiny, but compared to the size of the plane overall, it's pretty small.
Yeah. And send us questions and things that you want to have us chat about.
If you could do that, that would be great. And our email address again is blackboxdownpod@gmail.com, or you can do social media like Chris said. All right. Thanks for listening, everybody. We'll see you next time.
Bye.